Graph y equals negative x squared minus 6x minus 10. Well, what I could do is I could just pick some random x values and plug those in and see what I get, or I could use a little bit of common sense when I graph this. First things first, my leading coefficient is negative divisible 1. So I know that not only is this a parabola, this is a parabola that opens downward like so. If I find my vertex, I know that whatever point I get here, I'll get the same point over here. So what I'm going to want to do is find the vertex. That'll allow me to find the center of everything. And then I can start plugging in numbers over here. And once I figure out what those are, I get the same guys over there. So what is my vertex? Well, the vertex exists at y equals negative b over 2a, right? So you would be my a, you would be my b. So x equals negative 6 over 2 times negative 1. All right, so 3 negatives is going to make the whole thing negative. 6 over 2 is going to be negative 3. So the center of my graph is going to exist when x equals negative 3. Negative 3, not positive 3, negative 3. So let's make a table, knowing very well that my center is going to exist at negative 3, so x values, y values, negative 3 right here. So I'll plug in negative 2, negative 1, and 0. I'll plug in negative, well, I won't plug those in because I know what's going to happen already. But once I plug in negative 3, that's going to get me my tippy top. Okay, and from there I can get more points knowing very well that the left and the right mirror each other. So let's plug in negative 3 because that is my center. Okay, if I plug in negative 3, I'm going to get negative 3 squared minus 6 times negative 3 minus 10. So mental math, and it's not pretty mental math, but it's still going to be mental math. Negative 3 squared is 9. Negative 9 plus 18 is 9. 9 minus 10 is negative 1. So when I plug in negative 3, I get negative 1. When I plug in negative 3, I get negative 1, and that's going to be my tippy top. So at no point will this cross the x-axis. So I might run out of points pretty quickly. Maybe, maybe not. I guess we'll find out. But if I plug in negative 2, I'll get negative 2 squared minus 6 times negative 2 minus 10. Okay, negative 2 squared is going to be 4. So negative 4 plus 12. Negative 4 plus 12 is 6. No, negative 4 plus 12 is 8, and 8 minus 10 is negative 2. So when I plug in negative 2, I get negative 2, which means when I plug in negative, since this is the very tippy top, this is going to go like this. So if I plug in negative 4, I also get negative 2, so we're not going to overthink it. We're just going to put our dots over there. All right. See what happens when we plug in negative 1. Negative 1 squared minus 6 times negative 1 minus 10. Negative 1 squared is 1. Negative 1 plus 6 is 5. 5 minus 10 is negative 5. Okay, so when I plug in negative 1, I get negative 5. When I plug in negative 1, I get negative 5, which means when I plug in negative 5, I also get negative 5. All right, now the last guy is going to be friendly, but I have a feeling it'll fall off the graph. In fact, it will. If I were to plug in 0, I would get 0 minus 10, which doesn't exist on the graph. So I'm not even going to bother. You would be negative 10. You would be negative 10. It's not going to show up on the graph anyway. So when I graph this, it's going to be a nice curve. Try to draw it out as best as you can. I'm awful at drawing these, but that's what this is going to look like. So there you have it. All right. So there's my quadratic, there's my parabola. Fun, 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 fun.